So we'd love to solve a problem like this in SolidWorks, but before we can solve it in SolidWorks, you have to solve it in real life. So first of all, let's take a look. We have this little fake pole thingy, and it's got this force coming out, and we want to know what's the moment caused around this point A. So one of the first things that we have to do is we have to come up with a vector notation for that force. So generally what we're going to do is we're going to find the position vector from A to B, and we're also going to find the position vector from A to C. And the reason we do this is we know that if we go from A to B and then from B to C, that's the same thing as going straight from A to C. Why do we care? Because this allows us to write some math. So we know that going from A to B and then going from B to C is going to give us the same thing as when we went straight from A to C. That means we can find that R from B to C is equal to RAC minus RAB. The reason that we care is if we know what the position vector is from B to C, then we can convert that 100 Newton force into a vector, take a cross product, and get an answer. So we kind of have a basic plan. So our basic plan is going to be to find a force notation for 100 and then do a cross product and then get an answer. Yay! And if we're doing this in SolidWorks, why do we get an answer by hand? It's because we want to know for sure that we're going to do it for real if we get the right answer. So we're going to go ahead and work it out by hand and then compare it to what we get in SolidWorks and see how this goes. So first of all, we want to go from A to B. And if we look straight down on this, we have X and Y. And we have this little thingy, A to some other, let's call it D, A to some other D. Now we know it has a length of 5 and is 30 degrees there. That means the two components here along the X and the Y axes are 2.5 and 2.5 square root of 3. So if I go from A to B and then, or A to D and then up to B, I first have to go, let's see, 2.5 along the x-axis, and then I have to go 2.5 times the square root of 3 along the y-axis. This is again in the positive direction. So I'm going 2.5 this way, and then I'm going 2.5 root 3 this way, and then I'm going up 6. And that's how I get from A to B. To get from A to C is also relatively straightforward. I always have to make sure that I go in the x direction first. So I go 3 in the positive x direction, and then I'm going to go 2 in the negative y direction, and then I'm going to go up 7. Beautiful? Great. So I'm going to go ahead and I'm going to put this in my calculator. I have that the first one is 2.5 times the square root of 3, and 6. Oops, 6. All right. Then I've got my second one, which is 3, negative 2, and 7. Now what do I do with those? Well, I can plug them in. So I know that RBC is equal to RAC minus RAB. So this one is AC minus AB, and I get 5, negative 6.33, and 1, which kind of makes sense. So I just kind of look at it and I go, well, that does make sense, especially that the last term is 1, because I start at 6 and I have to go up to get to 7. So that's a good thing. So I'm in relatively good shape to get started here. Alrighty, and I don't need this anymore. Alright, so now that I have R from B to C, this is going to help me find the force notation for this vector here. Because the next thing I want to do is I want to find a unit vector from B to C. The way I find a unit vector is I need to go R, B to C, and divide by the magnitude of R, B to C. Now whenever I'm doing a magnitude, it's the best thing is just to do this, especially if I'm on a calculator, is do the square root of the dot product, because the dot product is just going to multiply. So if I do this, dot this, it's just going to multiply this related terms and square root it. So that's clearly the dot product. Alrighty. So whenever I come over here, I'm going to do the square root of the dot product of this guy with itself, So its magnitude is 6.43. So I'm going to take that vector and divide it by 6.43. So I've got this vector divided by 6.43, and then I've got this teeny weeny vector, so 0.0778, negative 0.985, and 0.156. So that is a unit vector going from B to C. Now that I have a teeny weeny unit vector here, so that's my teeny weeny unit vector. Now that I have a teeny weeny unit vector, I want to scale it by 100 because that's how big it is. So the force vector that goes from B to C is just going to be 100 times the unit vector that goes from B to C, like that. So 100 times the unit vector is, not surprisingly, the other thing with the decimal place moved over a little bit. So 7.78, negative 98.5, and 15.6. Now to actually find the moment, it's not too big of a deal either. I'm going to go R from A to B, crossed with the force from B to C. So it's literally just, that doesn't look very pretty, it's literally just what I did. So I have R, A to B. So this is the moment about A is equal to, because I've got this radial crossed with the force is going to give me the moment, because that's exactly what moments are. And so I'm just going to throw those straight into the calculator. So I've got the cross product, if I can find it, cross product of RAB, which is way up here, RAB, crossed with the force vector. And there I go. I've got a nice little magnitude, or not magnitude, I got a nice little vector thingy. 658, 778, and negative 280. Now, just in case I'm going to need to know this later, it's probably a good idea to go ahead and get the magnitude of that. So again, the square root of the dot product. That's not what I wanted. The square root of the dot product. One more. Of the two, or of the vector with itself. And that's because if I'm going to do this in SolidWorks, I'm probably not going to get the exact answer, just because that's how, doing things on the computer works, because it's an approximation, because it's solving it numerically, and I'm solving it exactly. That will give us the actual magnitude, and we'll see how close we get. So this is Newton meters. So now our next goal is, now that we know what answer we're looking for, let's go see if we can get this in SolidWorks. Now drawing this in SolidWorks is a little complicated because you're not doing exactly kind of something just in one plane, because it's coming out into the third dimension. So I'm actually going to go to the top plane and make a sketch. Just like that. Now, what I'm looking for actually is going to be along that 30-degree angle. So if you kind of look at what we had something that was off at 30 degrees. So what I'm actually going to do, it's kind of hard to see like this, what I'm actually going to do is I'm going to sketch this giant plane like this. I'm going to sketch this as a plane that kind of goes off at this 30-degree angle, so I can draw the entire structure, because my entire structure actually exists, this structure right here, actually exists in a plane that kind of goes like that. So that's my goal, is to draw that plane first, then I can draw the whole sketch on top of it. So let me at least get that plane off. So I'm going to first of all draw kind of a line here, and it doesn't really matter how long it is because I'm just using this for construction. I'll go ahead and make it 1. I'm also going to make sure I'm in the right units. So let's see, MKS, good, because I was in meters, that's excellent. Now I need to dimension this and say that this is at 30 degrees, but since I don't have anything that is 30 degrees right now to dimension off of, I'm going to go ahead and put that line in straight. And again, it doesn't matter how big that line is because it is just for construction. Sometimes just made it unnecessarily large. But what I can do is I can go from here to here, and I can type that in as being 30 degrees, and my 33 button is still broken, so 30 degrees, there we go. Okay, and this is just a silly little sketch, and it's not going to matter, except the fact that it's giving me this line, and that's the line that I'm going to use to make a plane. So I'll say, I'm going to call this, come on girl, initial sketch for, I don't know, object. All right, now I want to create a reference geometry. So I'm going to create a plane along that line, and it's going to be perpendicular. I always get this part wrong. Maybe a perpendicular to that? There we go. So I made it perpendicular to the top plane. So that is actually the plane. I'm going to right click it and say normal to. That is the plane that my object actually sits on. So I'm going to call this my object plane. Beautiful. Now my object plane is set and I'm normal to it, so now I can actually start to sketch. Right click, hit sketch, and I'm going to kind of create something that looks like this. Doop, 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 and doop. This is a very silly little sketch, but that's okay. Now, in order to make my answer as accurate as possible, I'm actually going to start marking some midpoints. So I'm going to go ahead and say that this is going to be, I don't know, 0.1 wide. This is going to be 0.1 wide again. And I'm actually going to go over here and I'm going to click point. I'm going to mark the midpoint. I'm going to mark the midpoints here. So if you go, there should be like a little indication that you've got the midpoint, that little yellow thing with the green dot. And that's so that I can refer to those midpoints later. Now, a couple of other things that I want to do is I want to now deselect point or hit escape. I'm going to zoom in a little bit. I'm going to select that midpoint and then I'm going to select the origin. Hit the shift key or the control key. Control key is better. And now I'm going to say I want to make those coincident. So what that's doing is it's centering ourselves right there on the origin. I'm going to hit F to make everything fit really, really nicely. And then I'm going to go ahead and make the rest of my dimensions. So I'm going to say from this midpoint to this midpoint in this direction is actually 5 meters. Hit F again to recenter it. Okay. And then I also know, there we go. I'm going to hit this midpoint again, and I'm going to scroll out. This midpoint to this midpoint is 6. Hit F again to get it in the right place. Okay, so now that's actually my beautiful picture. My object plane is much smaller than it needs to be, but it doesn't matter because it still knows what the plane is, and I can go through like that. Now if I exit sketch, I should have a fully defined sketch. So the reason that I calculated those midpoints is so that, you know, how would I know if I'm going to make this one 5 or this one 5? If you can see where I'm highlighting the bottom line 5 or the bottom line 5. So really, instead of doing one or the other, which would potentially mar my results, I'm going to split the difference by picking the midpoints and doing it in between the midpoints. So now I have my initial sketch. So this is my basic object sketch. And I can go ahead and do an extruded boss base. I'm going to actually go in both directions. I'm going to go 0.05 and 0.05 again because I'm trying to center kind of what I'm doing. So I'm going off in both directions. So I'm really kind of in the center of that plane there. And now I can see I've got that little L-shaped thingy going on there. A couple of other bits that we want to do. So first of all, we'll go ahead and we'll name this our main object. And I don't need these things anymore, so I'm going to go ahead and hide them just so they don't confuse me later. I'm going to come up here, so I'm hitting the scroll wheel, pressing down the scroll wheel and moving. I'm going to click on this and I want to add some reference geometry of a point. So it says face, center, face, and I'm going to name this point, this is my force point. And then I'm going to come over here, click on that, add another reference geometry, and this is my moment point. This is the point at which I'm going to look at my moment about. So I'll go ahead and go back to this guy. All right, beautiful. Now I need to figure out what line my force is going to be along. So again, if I remember what my original picture looked like that. And I need to create a plane that kind of goes through this so that I can go up 7 and then create a line that goes here. So the first thing I'm going to do is I'm going to create a plane that is parallel to the y-axis. So I'm going to create a plane that's parallel to the y-axis, but that's 3 off of it. And that way I can figure out where that point is going to go. So I come over here, and I'm going to create a new reference geometry of a plane. The plane is going to be away from the front plane by 3 meters. Beautiful. So if I show you my front plane there. So it's 3 meters off my front plane. And this is my plane for force, end point. All right, right click, normal to. Now this is actually going to go considerably off to the left, so I can go ahead and extend it, although it really doesn't matter. And I'm going to create a sketch. I'm going to make a line. Basically what I'm going to do is draw a line that goes 2 out and 7 up. So starting at the origin, I'm going to go 2 out, and, wrong direction, 2 out, another line, starting there, that is 7, up. Beautiful. And I can exit the sketch is fully defined. So, I don't really care what I call this. I can call it, I don't know, sketch-ish thingy. All right. Okay. Now my last thing that I want to do is I want to say, okay, well, I know that my force is going to go from my force point to that end point. So I'm going to scroll in, select my force point, scroll out, and I'm going to hit Control and select the other point. So I should have force point and sketches thingy here selected. Then go to Axis and create a reference geometry of an axis. Beautiful. Now I have this lovely axis that shows where my force is going to go. And this is really kind of exciting because now as I'm getting confused as to actually what I'm doing, I can look and I say, oh, okay, I see what's going on. I can actually hide this plane. And that might even help to show some of the other planes that are going on. Maybe not. I don't know. Basically, I can see, okay, here's my box that contains everything, and I can actually hide this other sketch too. So basically what's going on is I have this bar that's coming out into kind of a spacey thing, and I'm going to have a force that's going off in this direction. So this is one of the reasons I really like using SolidWorks to describe this, because it helps me see physically what's going on, because I can kind of get around it and look at it and get an eye on it. So remember that I said that this force, this unit vector, let's just look at the force, had 7 in the x direction, so 7 coming toward me, 98 off to the left, and 15 up. And if I look at that, I can kind of see, yeah, if I look at that force, it's going a whole lot to the left, coming toward me a little bit, and it's going up just a little bit as well. So I can confirm what I've done numerically and look at it and hopefully get a better idea of what's going on. Now the next step is to actually run the simulation. Run the simulation, study, a static study, and I don't care what I call it. Now I'm going to put in an external load, right click, force, and I'm going to say, select a direction, here along this line, I don't know if one, under point, I'm going to select force point. If you can't get force point there, you can open this up here and select force point there, and along the axis. Now I'm actually going to be using this one, which is an axial force. Select it to make it go and say that it's 100. Make sure it's pointing the right direction. Mine is. If yours is not, make sure you reverse the direction, but mine's pretty good, so I'm happy. Then I want to come over here and I want to make sure the other side is fixed. So I'm going to come over here, Fixtures, Fix Geometry, and I'm going to select that whole face if I can get to it. Not the moment point. Just the face. Beautiful. Okay. So I'm going to hide my other planes. Thank you. What did you just do? I don't know. So I'm going to hide my other planes because they are starting to get confusing. Because all I want to see now, I don't even know if I want to see the axis. There we go. So this is truly what's going on. I have a fixed point here and I have a force going off this direction. I'm going to have to apply a material. Since this is a statics problem, I don't really care what the material is. I'm just going to go ahead and apply it and I'm going to run the study. There we go. Right click results. And I'm going to, hopefully, with some kind of result for us, wait a couple minutes while SolidWorks catches up with what I'm doing and hope that it doesn't crash. I should have saved it, but I didn't. Click Free Body Force. I'm going to come over here now. Click on here. I want to know the moment point and with that face. Update, and there we go. Now you might get a little bit upset because these numbers are actually opposite in the magnitude or opposite in the direction as what we did. And that's because this is actually a reaction force, which we haven't formally talked about yet. But if we can just kind of like wave that under the rug and be like, okay, well, this is basically what moments would you need to balance it out. So what moments would I need to make this sum to zero? So it's basically what is the opposite moment that I would need to counteract this moment? So that's okay. Just, I mean, if nothing else, you know, it's exactly opposite, so that should be a little comforting. But then if you look at the resultant, you see that the resultant is actually 715, and that is what we calculated by hand. So I absolutely don't know how you could get a happier answer than what we have here, but this is really, really great. We're able to put this together, create it in SolidWorks, put in all the extra forces, and get the exact same answer out that we expected, so all is well with the world.